In the body page, drag a box node onto the work area. Let's change the dimensions of it. Go down to the Shape tab and change the X, Y and Z values to 1. And let's move the agent up above the ground. Now go to the brain page and drag an output node onto the work area. In the channel box, type in TZ and then set the range from 0 to 10 and move the slider to about 4 to 5 so that we can see some translation in the Z axis. Press the spacebar to play and then Alt F to follow the agent. Press Alt R to reset. Since we're going to be doing a simple terrain application, let's load up a terrain. Go to File, Load Terrain, and select the ground OBJ in the simple terrain following folder. Now let's drag in another output node and type in RY in the channel box. Set the range from -100 to 100 and set the value to about 30 degrees so that we have the agent going around in a circle. And as you can see, it's not doing a very good job of adapting to the terrain. Let's bring on another input node. And in the source, type in ground. This is going to give a value of the ground relative to the agent. Set the range to -10 to 10. We're going to need 2 fuzz nodes. One for high and one for low. To connect the nodes, hold down Control and click on the ground node, then click on the fuzz nodes. Now we need to define what the high and low fuzz nodes are to the ground. Go down to the graph and let's change the membership function to an S-curve. Select high, then do that. Have the start point at 0 and the end point at 4. And change this to linear. Same thing, the low fuzz node, change the curve to a Z. With the start point at -4 and the end point at 0. Change this to linear as well. Now drag on 2 defuzz nodes and connect them to the fuzz nodes. Starting with high, if the ground is high relative to the agent, we want the agent to go up. And if the ground is low relative to the agent, we want the agent to go down. We'll plug these into the output node and put TY into the channel. Give it a range of -100 to 100. Go to the up node and set the value to 100. And the down node's value to -100. Okay, let's see what happens. Oops. Well, we've got the agent going either up or down. But what happens if the ground is level? We need another defuzz node. And we'll call this 0. As we have nothing driving this value, we'll set this to else. So now 0 would be true to a degree when up and down are not. Let's see what happens. Oh, they plug in. Now the agent follows the terrain. But let's make this a bit more accurate and make the agent follow the angle of the terrain as well. Let's bring in another input node and type ground.dz into the source. The dz represents the slope of the ground in respect to the z-axis of the agent, and the z-axis of the agent normally runs from the front of the agent to the back. So in effect, this will tell the agent whether it is going up or down a hill and whether the ground is rising or falling. Let's bring on two more fuzz nodes. These will be rising and falling. Set the ground to -1 to 1 and then connect them up to the fuzz nodes. Now drag on selecting the rising fuzz node, go down to the graph and change it to an S-curve with the starting value at 0 and the end value at 1, making it a linear curve. And with the falling node, set it to a Z-curve with the starting point at -1 and end point at 0. Also setting it to a linear curve. Now drag on two defuzz nodes. So when the slope is rising, we want the agent to so when the ground is rising, we want the agent to tilt back. And when the ground is falling, we want the agent to tilt forward. We want this to rotate the agent along its x-axis, so drag an output node onto the work area and connect them to the defuzz node. Type in Rx in the channel box and set the range from -200 to 200. Tilting back would be a negative rotation, so set this to -200. And tilting forward would be a positive rotation, so set this to 200. We'll also need an extra defuzz node for when the agent doesn't need to tilt back or forward. And setting this as else. Let's see what the agent does now. We're getting close. At the moment we have an agent rising and falling and tilting back and forwards, but we still need to get the agent to tilt along its z-axis. We've got the nodes we need, so let's copy and paste them and make a few changes. Click and drag a selection over the nodes, and in Massive use the Alt-C to copy and Alt-V to paste. Click on the input node and change the DZ to DX and the output to RZ. Rising will become high left, and falling will become high right. So if the ground is high on the left, we want the agent to tilt to the right. And that would be a positive rotation, so the value would now be 200. And if the ground is high to the right, we want the agent to tilt left. And this would be a negative rotation, so change the value to -200. Press play. This is looking so much better. Now we have the agent following the train by rising and falling and tilting along its x and z axis. Now what if we want to control the rotation about the x and z axis? we're going to add some AND nodes, so let's make some space. Disconnect the fuzz and defuzz nodes by holding down the Ctrl-Alt keys and clicking on the connected nodes. Bring on the AND nodes, and then reconnect via the AND nodes. If you press play, the agent wouldn't have behaved as before. Great. We're going to drag on another input node. This will become our master control switch. Connect the input node to each AND node. So now, all these fuzz nodes can only be true if the input node is true. If the input node is off, we won't get any adjustments to the terrain along the agent's X and Z axis. To clean up the work area a bit, we can turn this part of the brain into a macro. Select the nodes and press Alt-G. You can see now the selection has been condensed into a macro. This will become useful when you have hundreds of nodes in the work area. To get inside the macro, hover the cursor above it and press Enter. Select the master control switch and press Alt-X to make the node appear externally of the macro. If we press backspace, this will take us out of the macro, and now the master control switch can be seen. Click on the macro so that we can change the name to something more suitable. If you click on the master control switch, you can see that it can still affect the nodes within the macro by moving the slider.